Yes, hey Litput fam, welcome back. And now let's solve same tree. Yeah, again, this is a pretty straightforward question, and this can be solved using both recursion and in an iterative way. So let's solve in both ways. So yeah, what is the question? You will be given two trees, and you have to just tell if they are equal or not. And what does equal mean? They should be structurally identical, and nodes should have the same value. And yes, just go to the example ones. This is not even though this may be structurally the same, but the nodes are different. And over here, even though the nodes are the same node values, the tree is not structurally the same. So yeah, how you can do? Let's do the recursive way first. So if p dot val is not equal to q dot l, then you can directly return false, or else uh, return is, yeah, since this is defined inside the same function, you have to have a self over here. P dot, we check for the left subchild, and the first you have to check for the left and the right child, and it should hold the same for the right child. And yeah, I think this might be it. Let me just check it once. And yeah, and you have to add a guard clause over here, because there might be conditions where one tree might become if nodes become null and all, then you have to add appropriate checkpoints. So if not p and not q, then you have to return true. If not p or not q, then you have to return false. This means you have reached the leaf, and all the other conditions are true. And this means that either one of the nodes exists, and that means they are obviously not identical. Just submit it once. Let us check it out. And yeah, it works. It is pretty efficient. And that was the recursive way to do it. And now let's solve it in an iterative manner. And yeah, if you want to solve it in an iterative manner and you look at it, there is again only one thing should pop into your head. And I'll give you a few seconds to think about it. Yes, you should not think about it also. Only one thing should pop into your head, and that is vertical order traversal. So what you can do is you can traverse the tree vertically and store the values in a dictionary, and then for each values in the dictionary and for each level, you can directly check out if all the levels are equal, and if the levels are not equal, then obviously the tree was not structurally identical. So let's directly do it. Let's declare the default dictionaries to store the levels in vertical order traversal. And again underscore q is equal to the same thing, and then you have to put the node in the dq. And yeah, I hope you know how to do vertical order traversal, because that is a must to solve this problem. So you have to have the root and the current level, and while q exists, for in for this in a length of q, and then underscore p at the position node, comma, you have to have node and level over here, level. Yeah, English is hard sometimes. At the level, what you will do, node dot val, and if node dot left exists, yeah, this is classic stuff. Whenever you are going left, you have to decrement the level, and if you are going right, then you have to increment that level. Yes, now do the complete same thing for our q tree, and again change it properly, underscore q, and then you can directly return the equivalence of both the dictionaries. Yeah, don't do like this. It is node, not node, and again it's node, not node. And yeah, patience is a virtue. Have it. and yeah, it obviously works. Let me just, I hope you know how level order traversal works, and if you know why, what level order traversal is and how it works, then you will understand why this solution also works. So yeah, just submit it once. Okay, yeah, again be sure to add guard clauses. So if not p and not q, that means both the trees are null and you have to return true. And if not p or not q, that means that one of the trees is empty and that means they are not equivalent, so return false. And yeah, let's just use this test case also. Always be careful to add guard clauses everywhere. See, I forgot to add guard clause and code obviously failed. That should not happen. And yeah, it works. Again, this is actually supposed to be pretty efficient, but I think my network is bad. That's why it's not showing that it's much efficient. And yeah, it's obviously like really efficient, but yeah, it uses a lot of memory. And but whenever you consider the recursive way, that uses stack memory, and sometimes the stack memory is not considered while lead code evaluates for space, so that might be super efficient. That might show that it's efficient, but yeah, obviously both are like almost the same. So yeah, grind more DSA and see you next time.